Hi guys, so today we're going to solve the Laplace transform of sine 2t. This is a particularly interesting problem. I say interesting because we're going to use a lot of cool results. But before we get into the actual problem, I'd like to prove a very useful result which we will be using in this problem. So this is the result. The Laplace transform of e power at equals 1 by s minus a, where s is greater than a. If you're already comfortable with the proof, you can forward to the part where we get to the solution, or I'm just going to dive into the proof. By definition, the Laplace transform of f of t equals f of s. It is a transformation which is the integral taken between the limits 0 and infinity e power minus st times f of t dt. Here f of t is e power at. On substituting this e power at in the definition of Laplace transformations, we get the Laplace transform of e power at equals integral taken between the limits 0 and infinity e power minus st times e power at dt, which gives us integral 0 to infinity e power minus of s minus a times t dt. We will solve the integral now. So we get e power minus of s minus a times t divided by the differentiation of this term, which gives us minus of s minus a taken between the limits 0 and infinity. We are now going to substitute the limits. Substituting the upper limit, we will get 1 by e power infinity only if s is greater than a, which makes this term positive, s minus a positive. So we get 1 by infinity, which is a 0, minus substituting the lower limit 1 by e power 0, which is 1. So we get a 1. Negative of a negative is a positive, and we get the Laplace transform of e power at equals 1 by s minus a. So this is the result, which we will keep aside for the moment. Let's get back to our question. Find the Laplace transform of sine 2t. We're going to generalize this question and we get the Laplace transform of sine 80. We know that sine of 80 equals e power iat minus e power minus iat by 2i, where I is the square root of minus 1. This can be easily derived from the Euler's formula. On substituting this in the place of sine 80, we get the Laplace transformation of sine 80 equals the Laplace transformation of e power iat minus e power minus iat by 2i. Now, Laplace transforms can be linearly split. That gives us 1 by 2i times the Laplace transformation of the first term minus the Laplace transformation of the second term. From the previous result that we've proved, the Laplace transformation of e power at equals 1 by s minus a. We're going to use this result, but instead of a, in this problem we have ia. So we're just substituting that in this result, and we get the Laplace transform of e power iat equals 1 by s minus ia minus the Laplace transform of minus iat equals 1 by s plus ia. Negative of a negative becomes a positive. From here on, it's simple mathematics. S minus ia times s plus ia gives us s squared minus of ia whole squared. I squared is a negative 1. The negative of a negative becomes a positive, and a squared. S and S cancel out each other. IA and IA give us 2IA. 2i and 2i here cancel out, and we get our solution. Laplace transform of sine of 80 equals a by s squared plus a squared. This is the general solution of the Laplace transform of sine 80. But in our question we have a equals 2. We simply substitute that, and that's our answer. The Laplace transform of sine 2t equals 2 by s squared plus 4. Hope this video was understandable. Thank you.